Okay, this one is going to be a standalone video because it is pretty complex. And once you know what to do, maybe not so much, but this one's a little bit tricky. First thing I recognize is we've got a sine theta over cosine theta. We're going to rewrite this, and I'm going to bring the 4 out front as just tangent theta dx. Okay, so this is tricky because tangent theta is not the derivative of any function, so we're going to have to think a little bit more deeply. So this time the theta is going to be the u, the du will just be negative 2 dx. But we're supposed to have a 4 dx, so I'm going to have to multiply both sides by negative 2. So negative 2 times du is equal to 4 dx. And now this thing matches this right here. Okay, so what do we have? So we have this thing right here that's going to substitute for that. So I'm going to put negative 2 tangent u du. Now this part right here substitutes for the 4 dx. Okay, now this is the quandary because there's not a function whose derivative is tangent, so we can't work backwards that way. But secant, remember the derivative of secant is secant tangent. Well, if there was secant in the denominator, so whose function would have secant in the denominator, then multiply the derivative of secant? That's the natural log function. So working backwards, negative 2 times the natural log. Remember, we have to do absolute value because you can't take the natural log of a negative number. So this kind of just secures that. Secant u. All right, and then we can replace. So f of x is equal to negative 2 times the natural log, absolute value of secant, negative 2x, that's the theta, and then the antiderivative of 0 is the constant c. Now, if you wanted to check that, take the derivative of negative 2 times the natural log. Well, if this is, here's the derivative. So negative 2 would come out front. And the derivative of a natural log is 1 over that function times the natural log of e, which then cancels. Now we have to multiply this times the derivative, well, I could leave that there, times the derivative of secant, which is secant theta tangent theta, times the derivative of theta, which is negative 2. So look what happens. We've got negative 2 times negative 2, which is 4. This secant theta cancels with secant theta, and what we have left is 4 tangent theta, ta-da, which is our original function. So it's a little bit crazy, but whenever you have to take the integral of a tangent function, remember you're going to have to take the natural log of the secant function. All right, that's it for this one.